So this question is given the series T sub k equals 2 times 3 to the k. And then it asks us, what does it mean for a sequence to be geometric? Well, let's take a look at T1, T2, T3, and T4, and then we'll answer that. So T1 is 2 times 3 to the first, 2 times 3, which is 6. T2 is 2 times 3 to the second, 2 times 9, which is 18. T sub 3 is 2 times 3 to the third, 2 times 27, which is 54. And T sub 4 is 2 times 3 to the fourth, 2 times 81, which is 162. And what you'll notice is to get from 6 to 18, we multiply by 3. To get from 18 to 54, we multiply by 3. To get from 54 to 162, we multiply by 3. We have a common ratio of 3. If we divide two numbers in order, you're always going to get a ratio of 3. So a series is geometric if there is a common ratio between two successive items. And again, here you pick any two numbers in a row, divide them out. The larger one divided by the smaller one is 3. So that's what gives us a geometric sequence. Now, what's the next thing it asks us for? It asks us for the sum as k goes from 1 to 7 of T sub k. Which means what? Which means T sub 1 plus T sub 2 plus T sub 3 plus T sub 4 plus T sub 5 plus T sub 6 plus T sub 7. Now we have many of these numbers already here. T sub 1 we have is 6 plus T sub 2 is 18 plus T sub 3 is 54 plus T sub 4 is 162 plus, remember, it's geometric, multiplied by 3. 162 times 3 is 486. The other way, of course, to get T sub 5 would be 2 times 3 to the fifth. 2 times 3 to the fifth is indeed 486. How about 2 times 3 to the sixth? 2 times 3 to the sixth is 1452. Excuse me, 1458. Plus T sub 7, that is 2 times 3 to the seventh. And that gives us 4374. So if we add up all of those numbers, what's our result? 6 plus 18 plus 54 plus 162 plus 486 plus 1458 plus 4374, and we get 6558. But I can also do this on the graphing calculator. Remember, we want the sum as t goes from 1 to 7 of T sub k, which would be the sum as k goes from 1 to 7 of 2 times 3 to the k. So I'm going to go ahead and I'm going to input this into the graphing calculator using the summation key, and hopefully we will get 6558. So let's go ahead and pull up the graphing calculator. I get this. Remember, I want the sum as k goes from 1 to 7 of 2 times 3 to the k. Math 0 is the summation. We are in alphanumeric mode, so k is here. K goes from 1. Whoops, down here actually. K goes from 1 to 7 of 2 times 3 to the k. 2 times 3 to the alpha k. And we hope to get 6558, and we do. So what else did we need to answer with this question? Determine whether the sum as k goes from 1 to infinity of T sub k converges or diverges. All right, so let's talk about that. The sum as k goes from 1 to infinity of T sub k. Sum as k goes from 1 to infinity of 2 times 3 to the k. Does this converge to a number or does it diverge? Well, what can we say about this? 2 times 3 to the k is a geometric sequence, so the sum of 2 times 3 to the k is a geometric series. Common ratio of 3. Common ratio r equals 3. Now, what do we know? A geometric series converges which means it's going to stabilize on some number when -1 is less than the common ratio is less than +1, and it diverges if it's greater than or equal to 1, right? Otherwise, the geometric series diverges, which means it goes to infinity, or it doesn't stabilize onto a real number. Otherwise, the series diverges. What it should say. So what we have here is we have a common ratio of 3. So all these numbers keep getting larger and larger and larger and larger, as I saw here on the previous page, right? 6 plus 18 plus 54, 162, 486, 1458, 4374. Each next number is multiplied by 3. So if you add them all together, there's no way it's going to stabilize onto a single real number. So in this case, again, common ratio is 3, so the series diverges. It goes to infinity. It doesn't stabilize on a real number.